Okay, thank you so much, Mr. Danish. Actually, Mr. Danish, you are unmute, so everyone not actually cannot listen to it. Okay, good afternoon, everyone, and Assalamualaikum warahmatullahi wabarakatuh. So, my name is Dr. Muhammad Aizat. So, I'm a PhD lecturer from the Department of Basic Health Science, Faculty of Masa, Faculty of Pharmacy Masa. So today I will give the webinar entitled this Pathophysiology of Schizophrenia and also the Antipsychotic Medication. Okay, and so I will start the webinar with describing about on the history of mental disorder classification, or basically on how actually that we learn to classify our mental disorder. Okay, a long time ago, right, during the ancient past, right, when actually like people are having these schizophrenic symptoms or manic symptoms, or this traumatic or uh, uh, this trauma, right? So they are actually that they're actually being believed that they're being possessed by the demons in their bodies, and some of them like believe that they're being punished by the gods for their immoral behavior. And during this time, right, the treatment, right, the treatment for this kind of the disease, right, they're actually that they what actually they make is that they will drill the whole of the skull of this patient, so that this hole are basically right will allow the spirit or ghost to to live from their body, from the patient body. Okay, so this trepanning, this method is called as the trepanning method, right? And is surprisingly the mortality rate for this procedure are not very high actually. Okay, and then fast forward, right, during the early 18th century, right? So during this century is actually is a rise of the psychiatric field study. So there are many psychiatrists are working on the psychiatric field. So during these times too, that we are actually being introduced with the term, for example, like melancholy, dementia precox, right? And this mania, this monomania, this idiocy, right? Is basically to describe about the symptomology of the mental disorder. And only at the turn of the 20th centuries, this German psychiatrist, right, in this picture, named Emil Kraepelin, right? So he used the terminology of dementia precox, which actually means early dementia, to describe the schizophrenia symptom. And why actually that he called as the dementia precox is because that he see that many of the patients are developing this disease during the adolescence. And he sees that this patient, right, when they actually develop this order, right, they cannot turn back to their previous mental capabilities before, prior to this development of this disorder. So that's why that he calling is as the dementia precox. However, in 1911, right, so another psychiatrist from the Switzerland, right, named Eugene Bleuler, right, so he criticized the definition of the dementia precox by the Amy Kraepelin. So he said that this patient, from his observation, that they also can develop this dementia precox not only during this adolescent and or early adulthood, but also during the later adulthood too. Okay, and that's why that he actually coined another term to describe about dementia precox, which actually he used schizophrenia. That's stick until today, these words. And the schizophrenia is basically is a Latin word, right? It's a Latin word, so it's coming from the word schizo, which means splits, and phrene mean minds. Okay, so this one is basically to describe the fragmental thinking symptom associated with the schizophrenia. And his work also introduced with these fundamental and accessory features of this schizophrenia that actually leads to our concept of negative and positive symptom of the schizophrenia that we know, that we use even until today. Okay, so what actually this schizophrenia is about? Okay, the schizophrenia is basically a mental disorder. It's a mental disorder of thoughts and also the volition. Okay, meaning the willpower. So this mental disorder, right, it will affecting the way that we think, the way that we perceive our real world, and the way our emotion, our moods, and also our motivation in doing our daily tasks. And the symptom of the schizophrenia can be divided into the three groups, right? The first one is our positive symptom. So positive symptom are actually the most obvious symptom in the schizophrenia, right? It's basically is a psychotic symptom. Okay, so psychotic we have two types, the hallucination and also the delusion. So what is the hallucination? The hallucination is basically the way that our brain perceive, right? Our brain perceive without a proper appropriate real stimulus. Okay. However, the easiest one, right? I'm sharing like my personal experience. Once I did my master, when I did my master, so I did interview with the schizophrenic patients in the psychiatric wards in the PPUM. So this patient very responded to the treatment, so I can talk to him. However, during the interview, right, another schizophrenic patient is interrupt my conversation. So he said to me that he said that I look very good, right? So I look very good, and then he said that his friend over there saying that I look like a prince. So I'm saying, who is your friend? Then he showed his friend. Actually, no one is there. Okay, so I understand at that time that he having this visual hallucination. It's meaning that he sees something that are not present in the reality world. And these visual hallucination are less common, right? So are less common. Compare that another hallucination, which is the auditory hallucination. The auditory hallucination is basically that they can hear like this sound, this kind of music that are actually not present in this reality. Meanwhile, for the delusion is basically is a false and firm belief, right? However, it's false, right? For example, if someone say that, so this type of this false belief, right? For example, right, if he believed that he is being spied by the top officer in the government, right? However, this patient background, right, doesn't explain on how actually the government want to spy on him, and then the story are also not very like comprehensive, and that's why actually indicating that this patient are having delusion. And positive symptoms are basically the most obvious one, right? And actually the most tolerated with the medication. Um, the most respond to the medication. And another symptom is the negative symptom, which is actually this patient of the schizophrenia will have this blunted emotional response, and also they also having this lack of motivation, and it actually that it has a subtle difference between the negative symptom and also the depression, this major depression symptom. However, we not go into that, right? And patient with the schizophrenia, they also will have like this cognitive deficit symptom. So it basically is impairing their cognitive function. And scientists has considered that there are basically the 7 domains of cognitive function that are being impaired in the patient with the schizophrenia, right? And however, the most notable one is the 2 domain, which are the working memories and also the executive function. The working memories is basically like the short-term memories. So for example, like if I'm saying to you, right, please remember these four numbers: 6, 9, 3, and 1. Okay. If you try to remember these numbers, right, in your brain right now, so it will be stored in your short-term memories. However, if I'm asking you, right, to do, please add 6 plus with 9 minus 3 divide times with 1. Then your brain basically need to hold these numbers. However, you need to do something with it, right? So you need to do the extraction and also the subtraction, right? So this one is basically is your working memory. Meanwhile, for the executive function, is basically is a high process thinking. Okay, so it's basically that we have the phonological loop and so this phonological loop is basically this high process thinking in our brain. And these two domains are basically the most notable one that being impaired in the schizophrenia. Okay, and so now we want to go for the etiology or what actually the cause of this schizophrenia. However, before that, I would like to explain on how actually that the schizophrenia are being diagnosed. The schizophrenia are being diagnosed by the psychiatrist at the psychiatrist ward or clinic, right? And they are based on the standardized clinical symptom criteria. So it's based on the clinical symptom. So currently that we're using this diagnostic statistical manual of mental disorder. Currently is number 5. So we have the list of the book from 1 to 5, right? So this criteria, right? This diagnosis, right? It make it rely on the patient description on the symptom, the examiner observation, the natural and also the family history, and also on the patient response to the treatment. In essence, that the diagnosis is not based on the etiological or no this pathophysiological data, right? Therefore, this real pathophysiological of the schizophrenia are basically that is quite complicated. Okay, it's quite complicated or undetermined. Mm. Okay, so now we want to go for the pathophysiology of schizophrenia. So it's the interesting part in this webinar, right? So what actually that is go wrong with the schizophrenia patient, okay? In terms of their physiology. However, to understand this, to appreciate this, right? So we need to understand about this neuron cells first. Okay, unfortunately that I do not know why actually the picture are not appearing. So in this slide. So sorry for that. So for this technical issue. But actually that we have the pictures over here at our right side. This is basically our neuron cell. Okay. However, yeah, without the pictures, right? So I hope that everyone can imagine that, right? That our neurons, right, are basically are made up like from three major structures. Okay. The first major structure is our cell bodies of the neuron that located of our nucleus. Okay. And then you have this axon, which is like a long projecting structures, right? And also the dendrite. Okay, and these dendrite are basically are the ones at the site that will receive this electrical stimulus, and it will transmitting this electrical impulse along to this reach the cell soma first, and then along to the axon until the axon terminal. So our neuron, right? So we have like billion of neuron in our body, in our brain, right? And then they are communicating with each other by using this electrical signal and also this chemical signal that we actually that this chemical signal we call it as the neurotransmitter. Okay, and our brain, right, consists of four different lobes, right? And each of the lobes, right, it has its own specific function. At the front, right, we call it the frontal lobe. So it's actually is functioning in the problem solving and also in producing the speech, which actually at the specific area that we call as the Broca area. Meanwhile, at the side, right, at the side of we have these temporal lobes, right? So this temporal lobe is involved in the auditory processing, okay, and then it also located is quite near with our ears, right, for this our auditory inputs. And at this temporal lobe, it also located of our Wernicke area, which actually functioning in comprehension of the language. Okay, so that means that for us, right, to understand what actually being said by other people, so this Wernicke area will be activated. And in the temporal area too, we actually located this one important region in our brain, which what we call as the hippocampus. So this hippocampus is important in the memory and also the information retrieval. And the third lobe is what we call as the parietal lobe. So this parietal lobe is located of our somatosensory cortex, which basically is functioning in the touch perception on how we perceive the stimulus, the touch stimulus, and it also involved in the body orientation and also in the sensory discrimination. And at the back of our brain is located of our occipital lobe, which basically is to receive the visual inputs from our eyes and also to interpret these visual inputs too. Okay, and other than that, that we have the cerebellum and also the brain stem too. However, I think that is we focus on these four lobe first because is these four lobe are basically are making up our cerebral cortex. Okay, and now we want to go what actually happening, what actually that we can see, we can observe from the brain of the schizophrenia. Okay, this picture, right, is showing the brain tissue when we cut it at the frontal plane. So we cut it like this, right? We cut it like this, and then we can see a clear part of the gray matter and also the white matters and also the brain ventricle, which is basically the brain ventricle is basically the brain cavities. Cavities mean like the empty space that basically is being filled with the cerebral spinal fluid. So what is the gray matters and also this white matters? The gray matters are actually the region in the brain which located at the outermost part of the brain. Okay, outermost part of the brain, and it made up of neuron of the cell bodies, the dendrite, and also the axon terminal. Okay, and at this area, there actually the synaptic contacts between the axon terminal and also the dendrite are happening. Okay, and however, we also have the gray matter inside of the brains, right, that located deep inside of the brain that we actually we call it as the basal nuclei. Why the white matters, right? These white matters are basically made up from the myelinated axon region, myelinated axon of our neuron cell. So this one, uh, so do not get confused that when it's gray and white matter, right? Even though that is called as the gray matter, however, in the real brain tissue, right, the color is basically is a little bit pink. So it's pinkish in color. So our brain, yeah, basically are pinkish in color. And in the gray matter, right, is basically the region where actually this high mental processing are occurring, right? For example, like the cognition, the emotion, and also the motivation. So the gray matter are basically a very important region of the brain. Okay, so we now go. Okay, So how actually that we can compare these neuroanalytical changes in the brain of the schizophrenia is because we have these techniques, the scanning, this very sophisticated scanning technique. For example, like this functional MRI, right? So it allows us to scan and compare the structural brain changes in the schizophrenia patient as compared to this normal people. Okay, so what actually the difference between the schizophrenia patient brains and also normal people, right? So in general, right, if we do what we can see is that the brain of the schizophrenia patient, right, they are reduced in their volume. Okay, so it's smaller in size. It's smaller in size. And what actually happening is that it has these tiny regions, especially at the prefrontal cortex area, which is at the frontal lobe, right? And at the temporal lobe and also at the parietal cortex. And here, right, it will uh, in total it will cause the decrease in the cerebral cortex size or the gray matter size of the brain of the schizophrenia. And it was also observed that this decrease in the temporal lobe and also the hippocampus size, which basically that it will be compensates or counterbalance with the increasing in the volume of the cerebral ventricle or the cerebral cavities, okay, which basically filled with the CSF fluid. And this loss of this gray matter, right? This loss of this gray matter or the thinning of this gray matter are not due to this neuronal cell death or this neuronal cell loss, right? So our neurons are not dying. However, instead, this tiny of the gray matter are basically due to the loss of the synaptic contacts, okay, meaning between the axon terminal and also the dendritic spine. And this loss of the synaptic contact is basically it may explain on why the patient with the schizophrenia is having the cognitive impairment, such as like the working memory and also the executive function impairment, because the synaptic contact, right, are very important in the high process function. Okay, so now you go for the next slide, right? Okay, so this picture, right, is basically is showing about this progressive loss of the gray matters in the patient of the schizophrenia as compared to this normal group of normal people. So here, right, as you can see, right, people with the schizophrenia, when we compare with the normal, so it have like the pinks and also the reds color, right, showing the significance areas that being reduced or in the schizophrenia. So this actually the regions that being reduced in the gray matters volume in the schizophrenia. So as you can see, we having these parietal lobes, right, and also the temporal lobe, and actually at the prefrontal lobes, we also have a little bit of the reduction in the gray matters, right, as compared in the schizophrenia patient. And this one, the picture is scanning by this MRI. Okay, and why actually these gray matters, right, are being lost in the patient with the schizophrenia. The best explanation for this loss of the gray matter are basically related with the reduce in the dendritic spine density in the patient with the schizophrenia. The dendritic spine, right, are basically a neuronal protrusions which consist of the heads and thin narrow spine of the neck. And when it's matured, it look like a mushroom. Okay. Okay. So this one is basically our neuron cell, which look like. So we have this dendrite over here, right? And then after that, we have the cell soma that containing our nucleus. And then we have these myelinated axons, right? And at the end, we have this axon terminal that basically containing the synaptic cleft, a synaptic vesicle that store with this neurotransmitter. And the electrical signal basically will be traveling from the dendrites to the cell body, and then this we have the action potential at the axon, and the electric signal will be propagating until this axon terminal. And here the electrical signal will be converted into the chemical signal in the form of neurotransmitter released to the synaptic cleft. Okay. However, if we look at the dendrite structures, right, of our neuron, and then we zoom it, our dendrite, then we can see our dendritic spines. And matured dendritic spine is look like a mushroom. Okay, matured dendritic spine is look like a mushroom. And the dendritic spine are actually the structures that are basically is highly dynamics in our brains. So it can change the shape from the mushroom become the Philadelphia like red structure. And it's very important for this synaptic function and also the synaptic plasticity. And the abnormal in the dendritic spine are associated with the psychiatric disorder, including the schizophrenia and also the mood disorder such as like the bipolar disorder and also the depression. And here, right, is basically is showing the evidence that the patient with the schizophrenia are having the reduction in their dendritic spine density. This picture showing this A diagram, right, is showing this in the normal people, right? The on how actually the dendritic spines look like. So we can see that the numbers of dendritic spine are quite high in this dendrite, right? However, if we compare the picture of A and we compare with the B and C, which are basically we got it from the schizophrenic patient, right? Uh, this patient, this author glanced at all, right? So he observed that patient with schizophrenia is having the less dendritic spine, as you can see from the B and the C. This one is basically showing the reduction of the dendritic spine density on the dorsolateral prefrontal cortex brain tissue from the schizophrenia compared with the normal subject. And um, and yes, so that's actually what actually happenings the neuroanalytical changes that are happening in the patient of the schizophrenia. However, we can go a bit deeper into that, into the genetic level, into the cell structures, right? However, I think that this webinar are not enough to cover for that, right? So I will proceed with the antipsychotic medication, okay, which basically the pharmacological parts. Okay, and antipsychotic medication, right, are the first line medication treatment for the schizophrenia. And antipsychotic drug, they have like two class, which is the first and also the second generation antipsychotic. The first generation antipsychotic are further classified as the low potency and also the high potency towards the dopamine D2 receptor. So the low potency is mean that this drug are bind with the low potency at the dopamine 2. This high potency is means that this drug bind with the high potency to this dopamine 2 receptor. And this high and also the low potency, right, it will influence on the adverse effect of this antipsychotic first generation. So the some of the drug, right, that we under the first generation of low potency is like the chlorpromazines, right? Meanwhile, for the high potency is like the one that very popular like haloperidol, fluphenazine, pimozide, fluoroperazine, right? And for the second generation antipsychotic, which is basically this atypical antipsychotic, or also known as the atypical antipsychotic or newer generation antipsychotic. The one that are very popular is like the acinapine, ariprazole, clozapine, lurasidone, olanzapine, and this quetiapine, risperidone, also this ziprasidone. And the first generation antipsychotic, right? Basically, on the mechanism of action of this antipsychotic is that they will competitively inhibits at the variety of the receptors. However, they produce the effect, the antipsychotic effect, based on this competitive blocking of this dopamine D2. And the first generation antipsychotic, the adverse effect of the first generation antipsychotic are associated with this movement disorder. And this one is due to this binding, this strong binding to this dopaminergic receptor. The example is like the haloperidol. However, this drug, right, the first generation antipsychotic are sharing similar effectiveness among them. So the first generation antipsychotic, you have this high occurrence of this movement disorder, including this extrapyramidal side effect, right? So the patient basically will produce this Parkinsonism or the Parkinson-like symptom. So the patient will produce like this muscle rigidity, this bradykinesia, which means the slow movement, and also the tremors. And their tone, the muscle tone are basically are being reduced, and also they're having this abnormal movement too, or akinesia. And tadi dyskinesia will be produced if, especially if they are, this patient are taking a long time treatment with this first generation of antipsychotic. So this study dyskinesia are basically this involuntary movement, involuntary muscle movement, especially at the face and also at the neck. Okay, so this actually pictures on how our the mechanism of action of our antipsychotic, right? So at the pre-synaptic, right? So it's containing our synaptic vesicle that storing our dopamine. So when actually this electrical impulse reach these presynaptic neurons, it will stimulates the release of the neurotransmitter into the synaptic cleft after the calcium influx happening. So this neurotransmitter, which is the dopamine, it will go and bind to the dopamine receptor, and then this one will basically it will stimulate the intracellular response. However, our antipsychotic drug, right, basically we it will go and bind to this dopamine receptor. However, when it go and bind, it will, the action is that it will produce this antagonist action. Basically, that it will blocks the dopamine neurotransmitter from the binding to this dopamine receptor. Therefore, when this blockade is happening, so this one will basically it will reduce the intracellular response, and this one in sort of way it basically it will alleviate the symptom of the schizophrenia. And the second generation of the antipsychotic drug, right, are basically as a newer generation of the antipsychotic, or we also call as the atypical antipsychotic. And this newer generation of the antipsychotic, it has a fewer extrapyramidal symptom compared to the first one. However, the side effect, right, this newer antipsychotic, it have like different side effect. It have a higher risk of the patient to develop this metabolic side effect. For example, like the patient basically will develop these weight gains, this hypercholesteremia, and also increasing the risk to develop the diabetes. And the second generation drug, right, is basically it also blocks on the dopamine D2 receptor. However, it will also block on the serotonin receptor too. So that's why that is actually it will reduce this extrapyramidal side effect. And the second generation antipsychotic is the first line therapy for the schizophrenia. It means that if you go to the psychiatric wards, right, and that if you being diagnosed as the schizophrenia, most likely you will be prescribed with the second generation antipsychotic drug. And the efficacy is equal to the first generation of the antipsychotic agent, if not more, right? And the drug selection will be based on the individual patient response. So either the patient are responding to this second generation antipsychotic or not. And the psychiatrists we also will consider on this comorbid condition of the patient too during the drug selection. Okay, so I think that's the end of my webinar. So I already cover from the pathophysiological of the schizophrenia and also the pharmacological component. So can actually learn a little bit from this webinar. So I would like to thanks to all for your time and your listening. Thank you so much. Mr. Danish?
All right. Okay. Thank you so much, Dr. Aizat. Yes. So if you have any question at all about his presentation, you can always send us a question on the at the same time, I would like to invite Dr. Aizat to the stage one more time. So, Dr. Aizat, that was very interesting, but I have a general question to ask. So, regarding schizophrenia, can we know what is the progress? So, why schizophrenia? Why is the field not progressing as quickly as it should be?
Sorry, Mr. Danish, can you repeat the question? As the line is actually not very good.
Yep. All right. Okay. So, Dr. Isaac, can I just know why is schizophrenia not progressing as quickly as the rest of the field? So, why is the medication for it? It's a bit hard for it to progress as a field, as a schizophrenia research.
Mr. Danish?
Hello, Dr. Isaac. Can you hear me? Hello. Hi, Dr. Isaac. Can you hear me? Hi, Dr. Isaac. Can you hear me, Dr. Isaac?
Okay. So I just received the question from Mr. Dennis. So basically, Mr. Dennis is asking, can I know why the schizophrenia research is progressing slowly as compared to others research in other diseases, right? So it's basically I think that what I can understand from this question is basically what are the challenges that the researcher that investigate about the schizophrenia facing. So compare, like for example, the cancer research or fatty liver disease research or the blood disease research, right? The most challenges that being faced not only for the schizophrenia research but also with the other mental disorder research is that we are very difficult, right, to get to investigate about the brain tissue. Okay, so we cannot get this the brain tissue of the patient, right? So to have the access on the brain tissue are actually are very difficult. And so we rely on so much on this MRI scan, so this scan technologies, right? And also we rely so much on the animal model. So actually these two are helping a lot in the animal in the research in the schizophrenia and also others mental disorders. And currently, like there are actually many genetic studies that actually flourish to investigate about this etiology, what actually cause the schizophrenia too. And so hopefully that's answering the question. So basically the challenges that we face, right, is basically to get the brain tissue. The best thing that we can do is that to get the post-mortem brain tissue of this schizophrenic patient. However, it's not easy to carry. So that's why that not many researcher, right, research can basically can investigate, can get a hold of the brain tissue. Yeah. Hopefully that's answering the question. No, Aisha, for psychotic drug, which generation always with you? No, Aisha said asking about psychotic drug, which generation. We all most of the time we use this second generation of antipsychotic drug. The second generation antipsychotic drug is the first line treatment of the first line antipsychotic treatment for this schizophrenia. And and for the first generation actually it's quite quite less frequently used anymore in the clinical. Okay, I think I got the message from Mr. Dennis. So I think that that's all for today. So unfortunately that we are having the technical issue. So I apologize so much for this. And um, you the audience can actually can comments on this on the comment section in the Facebook, and I will try to answer it in the comment section in the Facebook. Okay, thank you so much for listening. Have a great day ahead. Thank you.